Hello friends, welcome. I'm your friend, your host Roy. We are discussing series 1, real numbers. Today is webisode number 18. And friends, today we are going to continue a conversation about proving irrational numbers. This is third part of a three-part series. So today we are going to explore how or why we say these numbers like 5 plus, let's say 2 square root 3, or let's say 7 minus square root 5, why we say these numbers are irrational numbers. In the last two webisodes, we have actually proved different kinds of numbers being irrational numbers, right? We proved why these numbers are irrational numbers. Then we went on to prove why these numbers, a rational number multiplied by an irrational number, why such numbers are irrational numbers. Today we will take it up by one notch, where we have a rational number plus an irrational number. Why do we say these numbers are irrational? And again friends, this is a continuation. We did a lot more in great detail in our last class, series 1, about rational numbers, irrational numbers, and why all of these numbers are irrational, and we went into great detail to prove those. But we are going to actually put a different spin in these videos and find out an alternative way of proving them to be irrational. Now, like we did in the last two videos, we are going to do the same thing here. It is going to be our strategy that we will get the square root number on one side of the equation all by itself, and the reason will be exactly same as what we did in the last video. So let us start out by saying, let's say our number is 5 plus say 7 square root 2. I'm just randomly writing an irrational number. How can I prove that 5 plus 7 square root 2 is an irrational number? So like we have been doing, we are going to assume, how about we assume that 5 plus 7 square root 2 is actually a rational number. We will assume this to be a rational number, and then we know that all rational number can be expressed in the form of p by q, where p, q are integers, q not equal to 0. So now think about a strategy. We are going to try to get the square root 2 all by itself. So what we'll do, first of all, we'll take the 5 on the other side, or we are going to subtract 5 from both sides of this equation. So we will have here, if you take the 5 on the other side, you will be left with 7 square root 2 equal to p by q minus 5, right? Because we moved the 5 from this side to the other side. Now also, so if you were to just simplify this, what you will get is, you will have p minus 5 times q divided by q, right? Now we want to divide both sides of this equation by 7. Why? Again, our goal is to get only the square root term by itself on one side of the equation. So let's divide both sides by 7. So what we are going to have is square root 2 equal to, you will have 1 by 7 times this number, p minus 5q by q. Or in other words, just to put it simply, you will have p minus 5q divided by 7q. Now friends, here what is p and q? P is just an integer and q is just an integer. So essentially, if you look at it, you will have an integer on the numerator, and you will have an integer on the denominator. So this is nothing but a rational number, right? You have an integer on the top divided by integer on the bottom. So this is basically nothing but an integer on the top divided by integer at the bottom. And so this is a rational number. So we have square root 2 as a rational number. But we know that square root 2 actually is an irrational number. So we ended up proving that square root 2 is a rational number, which absolutely contradicts the fact that square root 2 is not a rational number. So why this discrepancy? This contradiction arises because of our incorrect assumption that this is a rational number. That is, we made a wrong assumption by saying 5 plus 7 square root 2 is a rational number. Because of that incorrect assumption, we end up getting square root 2 is a rational number. So our assumption is wrong, and hence 5 plus 7 square root 2 is not a rational number, but it is an irrational number. So it is very important, friends, to kind of understand the step-by-step how we are constantly looking to separate the square root term or the square root term all by itself on one side of the equation, because we eventually want to prove that the square root term is a rational number, which actually is not correct, and hence our assumption is not right, and so it is an irrational number. So how are you going to write it in your exam in a step-by-step fashion? So in this case, we have 12 plus square root 7, an irrational number. How do we prove it? So we again assume that that number is a rational number, and hence we can write that as in terms of p by q, right? Then we subtract 12 from both sides. And why in this problem we are subtracting 12? Because we want to get rid of 12, and then we want to get rid of 12, then we will have a square root term by itself. So we subtract 12 on both sides, so we have square root 7 equal to p by q minus 12. And just want to highlight here, because the strategy is to again get the square root number on one side all by itself. That is the reason why we subtracted 12 from both sides, so that we have only the square root 7 on one side of the equation, right? So again, moving forward, since p by q is a rational number, so p by q minus 12 is again a rational number, right? Because 12 is nothing but 12 by 1, so you have rational number minus rational number, you get a rational number. So we have square root 7 equals to p by q minus 12, and square root 7 equals to a rational number. But we know that this contradicts the fact that square root 7 is actually an irrational number. This contradiction occurs because of our incorrect assumptions. 12 plus square root 7 is a rational number. So 12 plus square root 7 is not a rational number, or we can say this is an irrational number. So friends, this is how we would be actually going ahead and proving such questions. Now this is going to be pretty much identical, that if you are given, how about instead of having that plus term minus term on the top, if you are given the same thing in the denominator, that if you are given, how about 5 plus square root 3, 1 divided by 5 plus square root 3, prove that this is an irrational number. You are going to really go about doing it exactly the same way, that let us assume this is a rational number, and we can write this in the form of p by q. And from there you can say that this term goes here and this goes here. What you will end up getting is you will have 5 plus square root 3, right? If this goes on this side, then you will have q divided by p. You will have actually q divided by p. Now you want to get the 5 on the other side. So what you will have is you will have square root 3 equal to q divided by p minus 5. So at this point you can say that this is a rational number minus this is a rational number. So if you subtract one rational number from another, you get a rational number. So what you have is, you have square root 3 as a rational number, but that is wrong, because square root 3 is actually an irrational number. And this confusion, this contradiction arises because of our incorrect assumption that 1 by 5 plus square root 3 is a rational number. Because our assumption is wrong, so it means that 1 divided by 5 plus square root 3 actually is an irrational number.